Am I live? I think I'm live. Let me just look on over at my other computer to check. Oh, there's some feedback, so I'm going to close that window, but it does seem to be streaming. I am currently streaming to myself. Okay. Good. Let's hop on over here, close that, let me just do a few things just to look at all of the various possibilities before I start really doing anything in earnest. Hello, I don't know if anyone's watching. I literally have no way of knowing. But if you are, if you are, I don't know what's happening with my other computer. There we go. Okay. So if you are watching, hello, and welcome to my the first episode of what I'm going to call season 2 of Built from Scratch. A while ago, about a year ago, maybe longer, I started a project where I was doing some YouTube tutorials for making a video game in Scratch. Did about 4 or 5 episodes, didn't do any more. Got sidetracked by all sorts of life stuff. With everyone in the world stuck at home, I decided that it would be a good time to start up again. So this is just a test stream. This is just a test, and I'm going to go through and just make sure that everything seems to be working, that I'm streaming, that audio and video are working, and we're going to do a simple project. We're not going to get started on the big project just yet, but we're going to start working on, make a little bit of some kind of Scratch game. So, hi everyone, I am Will, this is Maggie. Maggie's going to be working with us today as well. Hi Maggie, hello everyone. And what we are going to be doing today is we are going to be making a little Scratch game. What we're going to be doing in general on this stream, as I figure out the schedule and how much I do it and how much I work on it, is we're going to start from scratch. We're going to start with an empty blank Scratch project, and we're just going to keep working on a video game. We're going to go from nothing and make some kind of medium scale game, because I just want to go through the whole process of making something with a little bit of complexity, because it's one of the hardest things in programming, is thinking about how to take your project, how to take like the small pieces of your project and fit them all together so that you can see, so that you can make something bigger. So that's the plan for the long term. We're going to be making I have this grand ambition for a game design. You're going to fly a starship, you're going to go to galaxies and solar systems and visit planets, and it's going to be fun. It's going to be cool. You probably talk to some aliens. You'll probably mine resources. Mining resources is really fun. But that's all big and grand and ambitious, and it's not what we're doing right now. What we're doing right now is just making something relatively simple to get started and start testing. So what are we gonna do? Well, here we are. I have my empty blank Scratch project up here. I've got my Scratch cat, I've got my empty code thing, I've got my palette of blocks, and this is Scratch. So Scratch is, if you haven't used it before, it is a programming language that is designed to be easy to get started with for making kinds of visual, kind of multimedia, interactive visual kinds of things. It's really well suited for making video games and animations and, I don't know, just a lot of kind of visual expressive coding stuff. And it's free. You can go to scratch.mit.edu to sign up, make an account, things like that. And so here I am. I have a new project, a blank project, and I want to make something. The thing we're going to make today is we're going to make a simple, kind of the beginning of a platformer. A platformer is a kind of video game where you run and jump on platforms. It's kind of I've always thought it was kind of a odd thing to name it after, but But that's the genre. You know, think the original early Mario games where you run and jump and fall in pits and things like that. So we are gonna want to make a platformer. What are the really important things about this genre of game? Well, we're gonna need a character to control, and we're gonna need some stuff. We're gonna be able to need to run and jump on platforms. So that's what we're gonna need here. So I'm gonna jump into Scratch. This down here we have our sprites. Sprites are the things that go into your program. So we always start out with this little Scratch cat as a default sprite. You can move it around on the stage here. This is kind of like a preview window for what your project is going to look like when you run it. So we can make it full screen. We can shrink it back down to its preview size. I want a character. I don't want this Scratch cat, though. The reason I don't want this Scratch cat is not because I don't like it. I like the Scratch cat quite a bit. It's because the Scratch cat has a pretty complicated shape. It's got this little whisker popping out. It's got its tail here. And Scratch has built into it a really easy to use system for checking whether sprites are touching each other. And we're going to use that for checking whether our character is on the ground, whether it's hitting its head on a platform, things like that. And we don't want our cat to like hang by its tail or by its whiskers or anything like that. So I'm going to go here. I'm just going to click on this choose a costume. I'm going to click on paint. I'm going to make a new costume, and I'm going to delete these little Scratch cats. And I'm just going to make a square. Now, we're going to start with just the whole character being just a square, but there are ways that we could, later on, if we wanted our character to not be a square, we could still use the square shape as what's called our hitbox to check whether things are colliding with each other. I'm going to go here. I'm going to click on the square tool or the rectangle tool. I'm going to hold down Control. I think Control is Control is the button you hold down if you want to make a square instead of a rectangle. I'm going to drag this square around, and I'm going to put it in the center here. And so now the center of my square is the center of the costume. So this is called a costume here. One thing to note is that I am currently in what's called vector mode in the Scratch editor. There are two modes for Scratch. You can tell which one, here I'm going to make a new costume just to demonstrate. You can tell which one you're in. If I'm in bitmap mode, it has all these little kind of blocky, pixelated looking tools. And if I'm in vector mode, it has these smooth, clean lines. And this is because bitmap mode is, I'm going to zoom super duper in. Bitmap mode is a way of drawing that involves placing pixels on the screen. So the image that you have in bitmap mode is just a bunch of pixels. This is great for a lot of reasons. It's a very natural way to think about the computer graphics because your screen is just a bunch of pixels. But it's not the mode I want to use for this project. Mostly because when you are in vector mode, one thing that you can do is you can really easily edit the properties of your shape. You can resize it, you can move things around, and you can think of your art as being made up as a bunch of objects that are like distinct shapes, rather than being made up of just a bunch of pixels. So I can make a circle, and I can move the circle separately from the square here. And that's just kind of nice. So I'm going to go here. I'm going to delete these extra circles. This hitbox is fine. It's a box, which is the primary need that I have for this hitbox piece of art here. But I think we can make it just a little more characterful. So let's give it some eyes. Let's do this like kind of purpley eyeball here. That's one. I'm going to hit Control-C to copy that and paste it. And then I'm going to just move it with my arrow keys. Well, maybe I'll drag it. Maybe I'll click and drag. I was going to try to get it more precise, but whatever. We don't need to care that much. So now we have little eyeballs, and then for now, I don't know that we're ever going to care about what direction our sprite is facing, but when I am making placeholder art for a game, I like to have there be some obvious feature that tells you what direction the thing is facing. So I'm going to draw this weird little mouth here. This is like obviously crazy perspective. Who knows what's going on artistically, but this lets us know that the front, that the right side of our sprite is, that this is the right side and this is the left side. And so if we do need to know which direction our sprite is facing for any reason, this little feature will just help us know. Great. So now I have a character. I have a player. I'm going to name the sprite. By default, the sprite is named Sprite1. This is not a good name for a sprite. I'm going to call it Player Hitbox. Whoa, Maggie. Okay. I'm going to call it Player Hitbox. And I'm going to hop on over to the code, but actually I'm not, because I'm going to, before I do anything else, I'm also going to make the next part of the next kind of thing I want in this game, right? So as I said, we're going to be making a platformer. The fundamental action, the fundamental verb of a platformer is jumping. So we're going to need something to jump on and walk on. So we're going to need to make a ground sprite. I'm going to go here, I'm going to go to paint a new sprite, and I'm just going to grab a rectangle and I'm going to make the simplest ground there is. I'm just going to make myself a, let's just do a black square here. There we go. There's some ground. Again, what am I going to do? I'm going to go here and I'm going to say ground, give it a name. And I was going to say I don't want to belabor this point, but in fact I do. I am going to belabor this point. This is in vector mode. This is in vector mode. It's not in bitmap mode. The reason I'm making the ground in vector mode specifically is because if the ground is in vector mode, then I can adjust my level designs by making little platforms and dragging them around and seeing where they go. If it is in bitmap mode, I can't just grab little rectangles and shuffle them around. So it's just a lot harder to kind of play around with the design. So it's really helpful, really important for the way I'm going to be making this, that I make the ground in vector mode. And actually, I'm just always going to be in vector mode just because it's easier to work with when you're kind of prototyping things and fiddling around with stuff. Bitmap mode can be used for a lot of great art, and it is better for certain kinds of art styles. It is how computer graphics are ultimately going to be displayed on the screen. So there's lots of perfectly good reasons to use bitmap mode, but none of them are ones that I find compelling at the moment. So, okay, we have a ground, we have a player hitbox, and we have no code. So, I'm going to move the player here, and what do we want the player to do? Well, the main thing we want the player to be able to do, as previously said, is run and jump. But in order to do that, we need the player to kind of be on the ground. So actually, weirdly, before we make all these these things that seem like what the kind of fundamental things we want the program to do, we actually need to make the player fall, because jumping doesn't really make any sense without falling. Running on the ground doesn't make any sense unless you're standing on the ground, and standing only really makes sense if there's gravity, if there's something pulling you to the ground. This is true for, your simple 2D platformer video game design. It's also kind of philosophically true for physics in general. Does it really mean anything to stand if you don't have gravity? I'm going to say no, and we're not going to talk about it anymore. So, I want player hitbox, I want to just fall until it hits the ground. So to do that, we need to write some code. Code in Scratch is made up by all these little boxes here. These little blocks that can snap together. So, there's a whole bunch they're organized by categories. We have motion, which moves things around the screen, looks, sounds, events, control, all sorts of different things. We're going to use all of these categories of blocks. We might even use all of these categories of blocks today. Not sure. I haven't fully thought this through. We're kind of making it up as we go along. But so I'm going to I'm going to go to events here, the events category, and I'm going to grab this block here that says when green flag clicked. When green flag clicked it's kind of the start button for Scratch. So it's this thing here. It says go. You can see I hover over it. The tooltip says go. And it's the trigger for starting your Scratch project. It doesn't have to be. You can use other things like key presses and stuff like that. But by Scratch programming convention, the green flag is the start button. And so we're going to go with it. So when the green flag is clicked, what do we want to do? We want the player hitbox to fall until it hits the ground. So what does fall mean? Fall means move in this direction. And if you are paying attention to the screen here, you might notice that there are these numbers that change every time I drag my hitbox around. Right? I drag it all the way over here, and look, there. This number here says X, -234. Drag it all the way to the... Oop, I missed. Try again. Drag it all the way to the right, and now it says X 229. All the way at the top, Y 166. All the way at the bottom, Y -152. So these numbers are called the X and Y coordinates in our kind of coordinate system here, and they represent the location of the sprite on the screen. In particular, they represent the location of the center point, this point here of the sprite on the screen. So if I have the sprite exactly in the middle of the screen, it would be at 0, 0, right? So now the center point of the sprite is in the middle of the screen. It's exactly centered. So all of that's a bit of a digression. That's how we represent location in Scratch. It's how we represent location in general in a lot of programming and in a lot of mathematics. There are a couple of other ways that we can use numbers to represent geometric location. But the XY coordinate, the Cartesian coordinate system, is probably the most common. And it's a pretty intuitive one to think about, I think. So, as we move to the right, the X number gets bigger. As we move to the left, it gets smaller. As we move down, the Y number gets smaller. As we move up, it gets bigger. In Scratch, the center of the screen is 0, 0. So anything below the middle is negative, or to the left of the middle is negative, to the right or above is positive. So, all right, I said we were gonna stop that digression, but now we're actually gonna stop that digression because now we are ready to define what it means to fall. Yeah, we're ready to define what it means to fall. So when green flag clicked, we want our sprite to fall until it hits the ground. Falling means changing our Y coordinate, this Y value. It means making it smaller. It means subtracting some number from the value so that it, starts up here and then just kind of keeps going down until it hits the ground, right? Okay, good. So what do we need to do? We need to change our Y. There is, in the motion category, there is a block that it does this. We have change X, set X, here it is. Change Y by 10. So if I double click on this block, you can see the sprite moves up a little bit. Boop, 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 boop. Actually, if I single click on it, it turns out. It goes up by 10. If I make it -10, it goes down. That's great. This is exactly what we want it to do, but we want the sprite to change its Y value over and over again without us having to constantly click. Because if we have to constantly click on all of the blocks to make the game do the things that it's supposed to do, that would not be a very convenient system. There's a reason we have a computer. Clicking on this over and over again is, oh my babykин, it's okay. It's okay. clicking on this over and over again is the kind of thing we can get a computer to do, so we're going to get the computer to do it. So we want to repeat doing this over and over again as long as the program is running, because of course the sprite always needs to be falling. It needs to be falling the whole time. So in here, in control, there's a block. It says forever. And you can see this block has a different shape. Oh, geez, Louise, you're not into it. It's okay, baby. It's all right. It says forever, and we can snap this inside of it. So now it will do this over and over and over again. So if I click the flag, player hitbox goes all the way down and falls through the ground. That is mostly what we want to have happen. But of course, not entirely, because we want it to stop when it hits the ground. So what are we going to do? Well, now our hitbox is like lost in the depths of the ground here. So we need it to go back up. Oh, it's okay. We need to go back up to the top of the screen here. So I'm going to take a small break, maybe hand off this little baby, because she's maybe not loving programming. Sometimes she does, sometimes she doesn't. You know, we all have different moods. But, all right. So, 2 hands, ready to go. When green flag clicked, forever, change Y by -10. Player hitbox falls all the way through, falls through the ground. We need it to start back up here. We're going to be testing over and over again as we add little features. So one thing that's really nice to do when you're programming anything is to set it up so that it's as easy as possible to test what you're doing. So I could go down here and I could click on that and I could write 150 and I could write 150 and then press enter and it'll appear up there, and that's great. And then I can click again. Oh, it still doesn't work. Why doesn't it work? Well, I haven't changed anything, so of course it doesn't work. And then I'd have to go here and do that again. But actually, for the moment, I always want my sprite to start up in this corner because I'm testing gravity. I'm testing how gravity works. So I may as well, at least temporarily, go to motion, grab a set Y block, and stick it there. So now it says when green flag clicked, set Y to -150. I want to set it to +150. And now if I click the flag, we always start up. And that's great because we start in a position where we can see that our gravity is working, but our landing on the ground is not working. So, wonderful. We're falling. We're falling until we hit the ground, and then we are continuing to fall. So how are we going to change that? Well, we are going to use what's called an if-then statement, a conditional statement. We're going to check whether we're touching the ground, and we're only going to fall if we are not touching the ground. How do we do that? We go over here into control, and we grab this block that says if then. If blank, then nothing. So right now, this is not a very useful block because it checks if blank is true, and then if blank happens to be true, it says, okay, go ahead and do nothing. So we have to fill in this block with, the stuff we care about to make it do what we want. So what do we care about checking? We care about checking whether the player hitbox is touching the ground, and it turns out that Scratch has conveniently given us some easy ways to do that, and they are in the sensing category here. So look at the very first block in sensing, says if touching mouse pointer, but it has this little drop down arrow. I'm going to click on it and I'm going to choose ground. So now it's going to check if this player hitbox is touching the ground here. I'm going to stick it in. Boop. You see it kind of grows to fit, but you can see that this shape, this is a smaller version, but it's the same shape here. And all the Scratch blocks that accept other blocks, they kind of have a geometric representation of what blocks they accept. So that's pretty convenient. So forever, if touching ground, but change Y by -10, but that's not actually what we want because this will do the opposite, right? This says if I am touching the ground, then fall. So that says if I am already on the ground, fall through it. That is, as I said, not what we want, but it's so close to what we want. What we want to do is check whether we are not touching the ground. So I have grabbed this not block from the green operators section. So I can say if not touching ground, I can stick it there, and then now I hit go, and would you look at that? My player hitbox falls until it hits the ground. This is okay. This is not bad. There are some things that we don't quite like about this, though. One thing that you can see is that we kind of fall into the ground a little bit. So we're going to want to eventually fix that. But before we do, why don't we add some... We're just going to add a little bit more, add some stuff to make it a little more fun before we go ahead and like fix these small little fiddly bugs. Okay, so now we fall until we hit the ground. What did I say makes a platformer a platformer? It is the ability to run and jump. At the moment, we can do neither, but all we can do is fall and be stationary. But falling and being stationary is a kind of prerequisite for being able to run and jump. So there you go. We are going to add some stuff that the player can do, right? Because at the moment, this is not a game. This is a game where you click on the green flag and the thing falls and you watch it fall and then you click on the green flag again. There's not a lot of control. We can make this more fun by giving the player something to do. So we want the player hitbox to move to the left and to the right when the player presses the arrow keys. Right, if you press the left arrow key, I want you to go this way. If you press the right arrow key, I want you to go that way. And then if you press the up arrow key, I want you to jump. And we'll think about what jumping means in a little bit, but right now we are just going to go into we're going to go into control because we need to check some stuff. We want to make it so that if you press the left arrow key, you move left. You might notice that when I say that, when I express in English that need, I use the same construction that you use in programming. I say, if we press the left arrow key, then the sprite needs to move left. So what do you know? We need an if-then block. I'm going to stick it here right after this. We'll reorganize all this code in a few minutes after we kind of build this together. And you'll notice that as we work, we will just kind of willy-nilly, kind of haphazardly slap code onto the ends of things, throw it into place, whatever, see what happens. And then after a little while, we'll look at our code and be like, ugh, I don't like this at all. Let's go back and let's fix it. Let's make it a little easier to read, a little better, a little easier to understand, or keep programming on. But for now, I'm just going to stick it here. I haven't thought about where in our code we really want this. Should it go before the touching ground? Should it go after? Should it go in a whole other when green flag clicked? I don't know. So I'm going to stick it here. Whatever. It's not hard to change. If blank, then blank. We got to put some stuff in here to make this block useful. And what did I say? I said, if we press the left arrow key, then we move to the left. So how do we know if we press the left arrow key? Well, we use the same category of block that we did here, right? So if not touching ground, change y by -10. Cool. Down here, we have a block that says if key space pressed. Stick it in. If key space pressed, click on this little drop down, and I have access to a bunch of the keys on the keyboard. And I'm going to choose left arrow. So now we say if left arrow pressed, then do nothing. Not quite what we want. We want to move left. There is not a move left block, but there is a block that moves us to the left, and it is this one. Change X. Well, this block doesn't move us to the left. This block moves us to the right because it says change X by 10. So to move us to the left, we're going to say change X by -10. Click here, press the left arrow key. You can't see. Well, maybe you can. No, you probably can't. Press the left arrow key. I move to the left. Awesome. Super great. I press the right arrow key. It doesn't move to the right. I could just end up stuck back here. I can't move. Oh no. I am so sad. So now I want to do the same thing, but to move to the right. There's a lot of ways that you can do stuff in programming. This is the way I've chosen to write this code. There might be better ways. We may experiment with them later. But if key left arrow pressed, then change x by -10. Okay, now I want to do the same thing. If key right arrow pressed, change x by 10. And I can right click on this if block here, and it'll bring up this little menu. And I have these options: duplicate, add comment, and delete 3 blocks. I want to choose duplicate because I'm making the same code, basically. I'm basically doing the same thing. So I'm going to make a copy of it, and I'm going to change it. If key left arrow pressed, well, that wants to be if key right arrow pressed. Change x by -10, well, that wants to be change x by 10. Click the green flag, I fall down to the ground, I can go left, right, left, right. That's so great. I can now, the hitbox can run, the hitbox cannot jump. So what's next? I'm gonna hit stop, and I'm gonna make it so that we can jump. There are so many ways to do jumping. I'm gonna leave it at that. I'm just gonna start making one. And I'm not gonna worry too hard. There's if you're watching and you're like, no, why are you gonna do that? Why are you doing it like that? Well, I don't know. That's the way I'm doing it. You can do it differently. You can tell me why I'm wrong. Whatever. So for running, I decided that I wanted to use the forever if construction to check continually whether the arrow keys were pressed. Because I want you to be able to hold down the left arrow and keep going left, and hold down the right arrow and keep going right, and have it go quite smoothly. With jumping, I don't want you to do that. I want a single press of the up arrow key to make you jump. It's possible that I also eventually would like to give you some kind of control over how high you jump. Like if you hold down the arrow key for longer, you jump higher. That's really common in a lot of games. But for now, I just want a single key press to make you go up, to make you start to jump. So for this, because I only care about a single key press and not whether something is being held down, I'm going to use this block here that says when up arrow key pressed. This block, you can see it has the same shape as the when green flag clicked block. And it's called a hat block because it goes at the top of things. You cannot put any other blocks on top. What do I want to do when up arrow key pressed? I want to go up for a while and then fall back down, right? Because what's jumping? Jumping is moving up until you don't move up anymore. Jumping doesn't have our jumping code here doesn't have to include falling because falling is already handled. So jumping just has to involve going up. So how do we go up? I can go to motion. I can scroll down here and I can get a change Y. How did we go down? We changed Y by -10. So if I go here, I can change Y by 10 and I can press the up arrow. You can see every time I press the up arrow, I like hop up a tiny bit and then I fall right back down, right? Because I'm going up, changing Y by 10, and then I'm immediately changing Y by -10. If I hold this down for a while, you can see that it kind of starts triggering continuously. So I have up arrow key triggering continuously, moving me 10 up. I have if not touching down, triggering continuously, moving me -10 down, and so I kind of float in one place. But that's not what I want jumping to do. I want jumping to make me go quite a bit higher. So what could I do? Well, one thing I could do is I could say, okay, I need to go higher up. So this number here, change Y by 10. Why don't we just make it bigger? That gets us to go a little bit up. We want to go a lot up. All right, make a bigger number. Let's make it 100. Boop. And this kind of works. It kind of works. You could play a game like this, and it would not be impossible to design a game where this was the jumping. But it's not quite right. There's something fundamentally wrong with this jump, and well, there's a bunch of things fundamentally wrong with this jump, but the big one is that when we press the up arrow key, we start down here, and then we appear up here instantaneously. So we're not actually jumping. We're teleporting into the sky and then falling, right? And with 100, it's a little bit jarring, but it's not like horrible. But I can make it really big, and then you can see like you just appear up there. It's not a jump. It's something. It could be a fine game mechanic. It's not a jump. It's not what we want. So we are going to keep working. Instead of saying change y by 100, what if, all at once, what if we decide to change y by a smaller amount over and over and over again? How do we do that? Well, before, when we needed to do something over and over again, we grabbed this block that said forever. We don't want to jump forever, right? If in the game you press the jump button and then you just rocketed into the sky and then stayed in the sky for the rest of the game, that would also not be a jump. So we want to keep going up for a while. So we're going to grab this block that says repeat. This lets us just tell Scratch to do something a certain number of times. In this case, it says to do something 10 times. And so I could go ahead and I could change this number. I could put a 10 in here. And then what you'll see is I press the up arrow and I kind of float 10 above the ground for a little while. Why don't I keep going up? Well, each time this loop goes around, I go up by 10. But each time this loop goes around, I go down by 10. They go around at the same rate because of how Scratch works and how we've written things. I don't want to get too deep into how Scratch times its blocks at the moment. It's very likely that down the road in this series, as we are making something more elaborate, we have to care about that stuff. But I want to avoid caring about that stuff for as long as possible. So we're going up by 10, we're going down by 10. So we're staying in one place. So we need this to be a bigger number. How about 20? So that way, we'll go up by 20, we'll go down by 10. So we'll go up by a total of 10 each time around the loop. And I press, and now I have this jump here. And I can do it. I can run to the left, run to the right, and jump. And it's pretty good. It is pretty good. Oh, I did something. Let's see, can I fix it? Okay. You don't know because you weren't me. You don't know what I was doing with with the arrow keys there. I noticed something that was funny, which was that I right-clicked and brought up this little menu, and when I did that, my arrow key, Scratch stopped responding to my arrow keys, so then I pressed the arrow key, and then I brought up the menu, and then I let go while the menu was still up, and it didn't register the letting go of the arrow key, so the player was just running to the right forever and ever and ever, and I had to figure that out. But you don't know any of that. It was all invisible to you, and I didn't need to tell you. I did. So now you know, but I didn't need to. Okay, great. We have the ability to run and jump. This is cool. There are some issues that we might run into, and the way I'm going to kind of bring... Sorry. Again, you don't know what's happening with my mouse and keyboard, but I just remembered, or I just realized that when I use the scroll wheel to scroll up and down, Scratch counts that as pressing the up arrow key. So that's kind of funny. And that reminds me, that actually demonstrates to me one of my big issues here. You can see that I can fly in the air, right? There is nothing that prevents me from jumping when I am in the air. There should be for our game, right? We want the player to only be able to jump when they're on the ground. Again, you could make a perfectly reasonable game where you could fly, where you had a jetpack or whatever, and that would be fine. But that's not the game we want to make, so we're gonna fix it. So there's nothing in our code here that checks whether we're touching the ground before we jump, right? Our code is very, very simple. It's very clear about what it's supposed to do. When the up arrow key is pressed, what I do is I change Y by 20, and I do it 10 times in a row. That's it. You didn't tell me anything about ground, about checking whether I'm touching the ground, so I don't know why you're getting so upset that it's not, that you can jump when you're in the sky. You didn't tell me anything about that. That's what our script is saying to us in response to this perfectly legitimate criticism of the code. So, but our script is right. We didn't tell it anything, so it's just doing what we said. So really, it's not the script's fault, it's our fault. So, when up arrow key pressed, repeat 10, change Y by 20. This is fine, but we want to only do it if we're touching the ground. Over here, we said if we're not touching the ground, do this thing, fall. If we are touching the ground, we only want to be able to jump if we are touching the ground. So this is the same thing, but we don't need the not. I'm going to go to sensing. I'm going to grab the touching. I'm going to stick it in there. I'm going to shrinkinate this a little bit just to make it a little easier to see the code. If touching mouse pointer, no. Again, that'd be kind of an interesting game where I can only jump if I have the mouse, if I put the mouse at the spot. It's bad. It's a bad game. Let's not play it. Instead of touching mouse pointer, we're going to check if we're touching the ground. So now, if I press the up arrow key, I jump, and I can only jump if I am touching the ground. Again, you can probably hear it. I'm pressing the up arrow key quite a lot, but I'm not flying anymore. So I have solved the problem of flight, by which I mean I have made it so that our player hitbox can no longer fly and can only dream of flight. And you know, maybe one day we make a power up, and then player hitbox can fly and can realize that dream. But for now, player hitbox just has to be content being earthbound, like all of us legged creatures. So when up arrow key pressed, if touching ground, repeat 10, change Y by 20. All of that is fine. Let's add something that you might need to jump over. Right now we can jump. So let's add something that you might need to jump over. I'm going to go over here to costumes. I'm going to go into my ground, and I am going to grab a rectangle, and I'm just going to stick it here. I'm just going to keep it as all black. I'm just going to make it a little block here. Yeah, and that's that. And so this is my obstacle. And you can see I probably can jump over it. That's great. I can jump over it, so I'm just going to place it there. I'm going to call that good. I'm going to hop over here back to my code. I am going to, pardon me for one moment, because I think I realized, yes, I clicked start streaming. But I didn't click start recording. I meant to click start recording because I meant to be recording this so I could look at it later and test audio levels and things like that. So now I'm recording. We'll see. Although I meant to do them both the whole time, I'm gonna own that mistake. But in retrospect, it may yet prove useful to know whether there's a difference between the recording quality or the streaming quality when I'm recording versus when I'm not recording, and whether doing it this way taxes my computer too much. So I'm going to look on the bright side. Messed up the thing. Don't have the archive to review for most of it, but I did a small experiment. So, all right, fine. Okay, we've got 15 minutes left. I said I was going to do this for about an hour. So what I want to do now is add one more feature to this project. And it's a medium-sized one, because I've made this obstacle here. I've made this obstacle for you, the player, to have to jump over, but I don't have to jump over it. All I have to do is run right through it. And that is not good. That is not what I want. I want the player to have to stop when it hits the a wall here. And this ends up being a little bit complicated. Right? You can see a lot of like kind of not quite ideal things happen here. I can jump, and then if I stop in the middle, I can kind of hang on the ledge here. It's not good, right? So this gets back to a couple. This is a new problem, which is that we are not ever checking if we're hitting the wall when we're moving to the right and left. We are only checking if we are touching when we go down. So that it gets us to that problem, but it also kind of brings us back to an old problem that I mentioned before, the problem of falling into the ground here. So we're gonna kind of just address these things a little bit at a time, and just kind of think through how to fix all these bugs one at a time. We got a 10-ish minutes. We'll see how far we get. So the first thing to do is to note that I can run through the wall. I don't want to be able to run through the wall. So how can I fix that? Well, the way I make it so that I can't fall through the ground is I use this block here, if not touching ground, and I use it just before I fall. So why not do something similar with the arrow keys, right? Why not use the same basic construction to check whether I am touching the wall, because remember, it's all called ground. I'm calling this a wall, and I'm calling this the ground, but it's all one sprite. It's all one thing to look at. So I could say if only move to the left and only move to the, I'm going to zoom out a little bit, only move to the right if I am not touching the ground. But this is a little bit of a problem, because the way it works is that when I fall into the ground, right? So I'm always touching the ground if I'm standing, and so I can jump and move while I'm in the air, but I can't walk. This is like a potentially a perfectly valid movement mechanic for a game, one where you can move around by making a series of standing hops. But it is not the movement mechanic we want for our game. So what do I need to do? I need to make sure that when the player falls, they don't ever go into the ground. They fall up until the moment that they hit the ground, and no further. All right, this is a little bit of it's a medium complicated problem, and to solve it, we're going to need to use some medium complicated Scratch features. So we are going to go over here, and we are going to make ourselves a new block. I'm going to click Make a Block, and I'm going to hit cancel because I want to keep talking before I do anything else. Okay, so what do I want to make this new block do? Well, Scratch has all these built-in blocks for us that do things automatically. And we're using them, right? All these blocks Scratch has built for us to use. We can make our own blocks by combining these Scratch blocks and giving them new names. And I want to make some movement blocks. Right, we have this block that says change x by 10, which moves us 10 to the right. I want to make some movement blocks that move us, but they don't let us go into the ground. So it's going to be a movement block that doesn't let us walk through walls. And then we're going to kind of swap these blocks out. Everywhere we say change x, we're going to replace that with our own custom movement block. So I'm going to go here to my blocks. I'm going to make a block. I'm going to call it move x by, and then I'm going to add an input. Move x by, and then I'm going to say, I don't know, amount. Move x by distance? I don't know. Move X by distance, sure. And I'm going to select this little checkbox down here that says run without screen refresh. This checkbox is important. I'm not going to go too deep into how it works and what it does, but basically, we want all of our movement to happen all at once, invisibly to the player. If we tell it to move 10, we want the player to move 10. We don't want the player to move one at a time until it hits a wall. We want to move 10 and then stop when it hits the wall. To do all that, we're going to say run without screen refresh, so we can move our player around as much as we want, invisible, in an invisible way, and then once that's all done, once we have the player where we want, once we have the hitbox where we want, it will draw the change on the screen. I think that was probably a really horrible explanation, and I'll get into it more later. But I think it will make more sense once we've written this block. It's a little bit hard to describe what I want, what run without screen refresh does without some context. So what I want this block to do, instead of moving us 10, I want this block to move us one at a time until we hit a wall. If we hit a wall, then I want the block to step us back one so that we aren't actually in it. I want all of that to happen invisibly to the player so that the player only sees the movement right up to the wall, sees that you don't walk through it, but for the computer, it has done it one pixel at a time. So define move X by distance. We are going to say, now we have this block here that says move X by, and look, it says it's basically the same as this block. It has the same little number we can put in. Move X by distance. So what if this was 10? Well, then I would want move X by 10. I want move X by 10 to get the player hitbox to move 10 to the right. So how are we going to do that? Well, I want to move a certain number of times. So I'm going to say repeat 10. I think I'm making this up as I go along. So I'm going to say repeat distance, move X by distance, repeat distance, and then I'm going to say change X by 1. So what does this mean? This means move X by 10. That 10, this number here in this block, is equivalent. It kind of goes into is this distance number, right? That goes there. And so whatever this number is, that's how many times we're going to repeat. So this says move X by 10. So we're going to repeat 10 times, moving 1 pixel at a time. So I'm just going to take this change X by 10 here. I'm going to take it out. I'm going to swap this move X by 10 in. And this should cause no change to the behavior of our program. This should do exactly the same thing. And it won't have fixed any of our problems. And look at that. It doesn't. But I can still move to the right, just like I did before. Now, actually, this is maybe a good way to demonstrate. I'm going to turn off run without screen refresh here. I'm going to jump, and you can see what happens. Now I'm moving really weird, right? I'm like going a tiny bit at a time and doing these little falling things, and everything's very slow and strange. And that's because every time it moves, it changes X by 1, it's refreshing the screen. So it's, we get caught up in this step for 10 screen refreshes, 10 ticks, 10 units of scratch time. We don't want that. We want this to take the same amount. We want this whole changing X once. Nah. We want to change X by 1 10 times in the same space of time as Scratch takes to change X by 10 one time. So that's what running without screen refresh does here. Okay, so that's great. Our move X doesn't do anything new, but it doesn't break our program just yet. That's wonderful. That's amazing. Okay, so I'm going to swap out my change x by -10 here, and I'm going to say move x by -10. Awesome. Let's test it out. Oh, what do you know? What do you know? I'm pressing, you don't know. I'm pressing the left arrow key, and I'm not moving to the left. It works for going to the right. It doesn't work for going to the left. What gives? What's the deal here? Well, to understand what is going wrong, we have to, as usual, hop into our code and look at what is actually happening. So move x by distance. Distance is -10. All right, cool. So we're going to repeat -10 times, changing x by 1. But that's the problem, isn't it? You can't repeat something a negative number of times. You can't. At least I can't. I don't know what it would mean. I don't know what it would mean to repeat something a negative number of times. But more to the point, Scratch doesn't know what it would mean to repeat something a negative number of times. So, I can't repeat. You just use a repeat distance here, right? If I have a negative distance, I still need to repeat the positive number of times. But instead of changing x by a positive number, I need to change it by a negative number. Okay, how do we do that? I guess we have to check something. If we are checking something, it probably needs to be an if-then statement. I'm going to use an if-then-else statement. Yeah, we'll do it like this. I don't know. There's probably other ways to do it. So, if-then. So what do we need to do? We need to say if distance is greater than 0, we're going to repeat distance times. And distance is less than 0, we're going to repeat the positive version of distance times. Okay, so how are we going to do that? We're going to go into operators, we're going to grab a greater than sign, and we're going to say if distance is greater than 0, repeat distance, change x by 1. So again, our right arrow key is working. It's always been working. It's still working. Our left arrow key is definitely not working because we are very explicitly only handling the right arrow case here, right? We're saying if distance is greater than 0, do this. Okay, so what's the left arrow key? If distance is we have this else here. So this says otherwise, if distance is not greater than 0, we're going to repeat a different number of times. We're not going to repeat distance times. We're going to repeat, down here, we're going to repeat the abs of distance. Abs of distance. Abs stands for absolute value. So, absolute value is a math term for the amount of a number. There's a sense in which -1 and 1 have the same amount, but a different direction. So, the absolute value of -2 is 2. The absolute value of -17 is 17. The absolute value of 0 is 0. The absolute value of distance is whatever the positive version of distance is. So, we're going to repeat the absolute value of distance, and we're going to change x by -10. No, not by -10, by -1. Now, okay, so now look at that. That's pretty good. We still have the problem where we can't run, and we fall into the ground. Right, we still have that problem. But we do have the ability to go left again. So we haven't broken everything. And it's a little bit hard to tell, but we can't quite go in, and we can't walk through the wall. So that's pretty good too. We still fall into the ground. So because we've only made a move X, right? We haven't made a move Y. So let's do that. I can't. I was gonna right click on this and duplicate it, but apparently you can't. So I'm gonna go over here to my blocks. I'm going to make a new block. We're going to do the same thing for Y as for X. We're going to say move Y by, add an input. We're going to call it distance. I think I called it distance before and not amount. I'm not certain. I'm going to click run without screen refresh. I'm going to click OK. And I'm going to zoom out. I'm going to hop over here, just grab a little bit of extra space, zoom in a little bit. Okay, What is this going to do? It's going to do all the same things. It's going to do literally all the same things, but instead of changing X, we're going to change Y. It's going to be 1. And down here, it's going to be -1. I see no reason why this should not work, but I'm not actually using it yet, so that was not a test of anything. All right, now we say change Y by -10. Cool. We're going to replace it with our own custom move Y. We're going to say move Y by -10. And then here we say change Y by 20. We're going to do the same thing. Move Y by 20. Okay. Now we are jumping and falling and stuff. But again, we haven't actually changed anything about this program. We said the whole point of this, was going to be to stop us from walking through walls. But we actually haven't done that yet. There's still nothing in this code that stops us from, well, I guess we have, right? Because we said this if not touching ground. So we did stop us from walking through walls, but we didn't. We have yet to make it so that we're not stuck and standing in one place. Because what's happening again? Why didn't this fix it? I said this would fix it. Why did I lie? Well, to solve our problem, we have to think about the code and what it's actually doing. And here we're saying, move, our move Y. Nothing in here is actually caring about whether we're hitting the ground, right? So we can still fall a certain amount and end up intersecting the ground. So, how do we fix that? We need, I said that the point of all of this was to move one at a time until we hit the ground and then stop moving. So what we can do is in each of these changes, we're going to grab an if. We're going to say if not touching ground. If not touching ground. And I think I think this explanation has gotten a little bit dubious, but I'm going to just throw this code in here, and then I'm going to talk about it. So, and I'm going to do this for X and for Y at the same time. And I'm just going to note out loud that I'm writing the same code in a bunch of places, and I'm copying and pasting code. And we don't generally think that's a great idea. Anytime you're copying and pasting code, you should usually think to yourself, think seriously, think hard about whether you could have the computer handle the repetition, because it's not great to have a human handle repetition when a computer could do so. Okay, so now we are in sort of a better shape and sort of worse shape, because now what? Well, okay. Now I fall pretty smoothly, and you can't really tell, but I'm not intersecting the ground, or rather, I'm not intersecting the ground very much. I'm still intersecting the ground a little bit, and the easiest way for me to notice this problem is that, look, I'm pressing these left arrow keys, I still can't do anything. I still can't run left and right, because I'm still in the ground a little bit. Why is that? Well, just think about what this code does. It says, if not touching ground, change Y by 1. So I keep changing Y by 1 until I hit the ground. And then I don't do it anymore. But I've already hit the ground, so I need to back us out, right? We're going to go tick, 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 tick. We're going to move forward a bunch of steps. We're going to hit the ground. We're going to back out. After we've done that, after we finish moving, we're going to back out and make us not be touching the ground anymore. So let's see. How are we going to do this? We're not going to do this in a way that... So this is definitely going to get a little bit out of hand, but we're going to say, all right, we finished this. So now if distance is greater than 0, if we are touching the ground at the end of this movement, if we've moved 10 and we're touching the ground, or we've repeated and we're touching the ground, we want to step back 1 step. But we only want to step back 1 step if we're touching the ground. So we're going to grab an if statement here. We're going to check if we're touching the ground. Check if touching ground, that's sensing here. Touching ground. We're going to do this in both spots. If we are touching the ground after we've completed our move, if we were moving to the right, we want to go left. If we were moving to the left, we want to go right. How do we do that? If distance is greater than 0, that means we were moving to the right. So we want to change x by -1, else we want to change it by 1. Same thing here. If distance, and we are over time, but I'm gonna finish this anyway. If distance was greater than 0, if we're touching the ground, distance was greater than 0, we're gonna change y by -1. And otherwise, we're gonna change it by 1. So now we have, look at that. I'm not quite touching the ground. I'm 1 pixel away from the ground. That's really great. It's really awesome. But there is a problem. There is a problem, which is that I can't jump anymore. Why can't I jump? Why can't I jump? Well, if the up arrow key is pressed, I check if I'm touching the ground. I'm not touching the ground. We did all this to make sure I wasn't touching the ground. Now I want to know if I am touching the ground. Jeez Louise. Okay, so there are more ways to solve this problem. If we return to this project, to make a good platformer character controller takes a lot of hard work. There's a lot of little wrinkles to think about. I'm going to do something in a really haphazard way. What I'm going to do is I'm going to say, when I press the up arrow key, what if I just move down 1 pixel? Just one pixel, and then check if I'm touching the ground. If I'm not, I'll move back up that 1 pixel. So when up arrow key pressed, I'm going to go down 1, just 1 pixel, change y by -1, and we're going to here. Oh, and that's not right. That's not right at all, is it? Something has gone awry here. When up arrow key pressed, change y by -1. If touching ground, then repeat 10, move y by 1. So if change y by -1, if touching ground, I did want to say if else here, and then I still think maybe I have caused some problem. But we're going to investigate it. If we are touching the ground, we're going to change y by -1. Great. First things first, change y by -1. If we're touching the ground, we do this. But this is weird because it means that I end up falling into the ground. And the reason is because all of this expects me to not already be in the ground. But what I'm doing here, I'm moving into the ground and then triggering this. And so none of it makes any sense, right? This code doesn't make any sense if I'm in the ground. It is all based on the idea that I should never be touching the ground. Nothing should ever make me touching the ground. We should only ever use these blocks, and they will prevent us from ever touching the ground. So I need to make sure I'm not touching the ground before I do this. So I changed y by -1. I checked if I was touching the ground. Now I need to move it right back up again. Change y by 1. Right? So I'm just going to go down, just tap the ground, see if it's there. If it is there, I do this jump. If it's not there, I don't do the jump. But I still want to move up the 1 pixel. So does this work? I think it doesn't. Oh, that says change X by 1. That's a problem. This wants to be change Y. Put it there, change Y by 1, hit go. All right. This is okay. We can now run and jump, and we can land on the platform, and it's all working pretty smoothly. And I can hop into the ground here, and if I'm feeling like I want to do something fun, I can just kind of add platforms around, and then we can play this little game here. Hop from place to place. Pretty cool. Okay. So I'm gonna call that good. I'm gonna go up here. I'm gonna say goodbye to anyone who's watching. Thanks for tuning in for this test stream. I have no idea how it worked. I have no idea whether anything I said or did was audible or interesting. But there you go. This is currently called Untitled 2. That's a bad name. Just like I named these sprites down here, I'm going to name my project. If there's anything you take away from this programming tutorial, it's to name things well, I hope. So, Untitled 2, bad name. I'm going to call it Test Stream Platformer. I don't need a period there. I'm going to click over here. I'm going to say save now. Make sure it's saved. I'm going to say C project page. I'm going to click share. If you want to look at the code, if you want to build off of it or do anything else, you can go to search for built from scratch on the Scratch website. And you can remix it and play around with it. Thanks everyone. This was fun. I've been Will. And I hope that tomorrow at lunchtime I will also do this, but we will begin a different project. Starting from scratch again, not making a platformer this time. This is just something that I thought would be a good, easy self-contained thing to test. So that's what I did. We're going to start on a different project and start from scratch. So feel free to, if you think someone would like it, they don't have to have seen this one to start to follow along. And yeah, have fun. Take care, and I will see you all later. Thanks. Bye.